Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Reni Lestari. I'm from State of Polytechnic Negeri Malang. In this video, I will presentation about electrical control instrumentation of steam turbine, including power generator. Steam turbine system. In turbine startup process, as emergency stop valve is fully open, turbine speed increases and at this point governing control valve will take over. Superheated steam flow into turbine then is controlled by governing control valve. Set point of governing control valve output is based on megawatt set point or speed set point. The set point later will determine the output control of governing control valve. Soon after steam enters turbine, expansion is take place to convert steam enthalpy energy to mechanical energy through several stages. The expansion takes place through a series of fixed plate nozzles that are concentrically arranged within the circular turbine casing and moving blades which is attached on the central turbine rotor. Each row of fixed blades and moving blades is called a stage. Steam pressure and temperature will dramatically reduce when it reaches the last stage. This steam will be condensed by surf condenser after steam turbine. Condensation will rapidly occur in lower pressure. To achieve true condition steam, ejector is equipment after condenser to prove vacuum pressure. Finally, condensate will pump to boiler, aerator, or water tank and continue the Rankine cycle. Next is governor. Governor is component of the turbine control system that regulates rotational speed in response to changing load condition. The governor output is signal manipulate the position of a steam inlet valve or nozzles, which in turn regulate the steam flow to the turbine. Function reach parameters that are used to determine the opening of the control valve that aims to regulate and maintain the turbine rotation speed. The governor output signal to the steam inlet valve or nozzles is set from two control modes: is startup speed controller and speed or load controller. The startup speed controller proved override control during the startup sequence of orderly rampage of the steam turbine through multiple warm-up phases. Once the unit reaches load speed, the startup speed controller continues to ramp until its maximum set point value is attained. During the starting a warm-up sequence, the startup speed controller manages the ramp rates from state to state, the speed at each stage, and the well time of each speed plateau. Typically, the ramp rate between the states are slow to avoid rapid and uneven expansion of the steam turbine components during the warm-up period. In virtually all steam turbine systems, there are opening speeds known as critical speeds. Critical speeds are operating regions where the rotational frequency near the critical frequency, and that's high vibration occur. In this region, two governor ramp rates are increased to provide more rapid acceleration through the critical band, and that's minimize the level and duration of critical speed include vibration one-step up speed controller. Brings the steam turbine to the load and rate speed. Control is transition to speed or load controller. Next is type of governor system. The main function of turbine governor is to maintain the shaft speed constant if the load varies. There are 4 types of governor system in a steam turbine, and function of each type there are: 1. Throttle governor. As the load decreases, shaft speed increase and stop valve is partially closed and admit less steam to the turbine and to produce less power according to the demand. Number 2, nozzles governing. Nozzles are generally made up in shafts. Each shaft being controlled by a separate valve. With the decrease of load, the required number of nozzles may be shut off to get the desired steam flow. Number 3, bypass governing. When there is no overload, additional steam may be admitted through a bypass valve to the latter stage of the turbine. They generate more energy, satisfy the increased load. Number 4 is emergency governing. It is used when 1. Subspeed exceeds 110% of its rate value. 2. Lubrication system fail. 3. Condenser become hot or due to inadequate cooling water or vacuum loss, etc. Next is part of governor. Number 1 is speed control shaft and pinion. Number 2, speed control rack. Number 3, adjusting screw. Number 4, locking plug. Number 5, rocker arm. Number 6, maximum RPM adjusting screw. Number 7, governor spring. Number 8, governor wake. Number 9, governor shield. Number 10, governor spring collar. Number 11, bar wrench. Number 12, pivot. Number 13, governor shield carrier. Number 14, control valve. Number 15, featuring valve spring. Number 16, featuring valve. Number 17, relay valve. Number 18, relay valve spring. Number 19, driving shaft. Number 20, boost pump driving gear. Number 21, boost pump idle gear. Number 22, dumbbell valve. Number 23, valve spring. Number 24, adjusting gear. And number 25, engine mounting joint. Next is governor's working principle. Basically, the way a governor works is simple. Just rely on engine rotation speed alone. A governor is connected to a shaft spin. A pair of pendulum is connected to the shaft. Pendulum it rotates along with the shaft rotation. Centrifugal force that occurs due to rotation causes the pendulum toss. The pendulum is connected to the collar on the shaft. The collar will rise accordingly by moving out of gravity on the pendulum, and if the pendulum moves down, then the collar will move down. The collar movement is used to operate or set the flow lever on a diesel engine or slow fluid in gas or steam turbines. spin rotation is kept at the desired set point value 300 rpm, so that the axial electricity generated by the generator stay at certain frequency, which is about 50 Hz. Next, control valve. Control valve is device used to modify fluid flow or pressure rate in process system by using power for its operation. Control valve function. There is 4 control valve function. Number 1, to close and open flow on condition. When it is open, it has a minimum flow resistance and pressure loss. Number 2, for the purpose of regulating the flow. By holding the flow with a change in direction of using an obstacle, it can also be a combination of both. Number 3, to and backflow, usually using the check valve, lift check and swing check. This valve will remain open and will close when there is flow in the opposite direction. Number 4 is pressure relief. Using a relief valve and safety valve. Relief valve is used to overcome when there is excessive pressure that can interfere with the drainage process or even the failure of the draining process. Well, while the safety valve using spring leader, this valve will open if the pressure exceeds a parameter limit. Next is butterfly valve. An example of a type of control valve is the butterfly valve. Butterfly valves are formed from discs that rotate in the flow path to regulate the flow rate. The shaft is centered on the axis of the pipe. The discs draw a narrow section of the drain pipe. This hole minimizes wear and reduces friction. Control of the valve in the closed position can complete the flow because it requires torque for the output to pull the valve out of the seat. The advantage of this type of butterfly valve are large capacity, low pressure loss, and applied to slurry. But the losses or torque are large, affecting limited flow, average 0 until 60% taxon of required special medicine. And this is reference that I used to make this presentation. Yeah, that's all from me. That's all from my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.